Here's something surprising. Every video you stream taps into massive data centers, and while each minute uses only a small amount of power, it adds up quickly when millions of people are watching.
Those numbers are staggering when you think about the scale. We've gone from just 259 hyperscale data centers in 2015 to over 1,100 today, and they're still building more.
And we're talking about facilities that make shopping malls look tiny. The market is already at $167 billion and projected to hit $600 billion by 2030. Each one of these centers needs more than 40 megawatts of power. That's enough to run about 32,000 homes.
So, what's driving all this explosive growth?
Well, it's primarily AI. The computing requirements are just astronomical. The GPUs they're using have gone from consuming 300 watts to 1,200 watts each. When you pack thousands of these chips together, you're essentially creating a small power plant in each server rack.
Hmm, that must create some serious cooling challenges.
Oh, you have no idea. Traditional air cooling is completely useless at this point. They've had to switch to liquid cooling systems, literally submerging some of these components in special non-conductive fluids. It's like trying to cool a blast furnace. You need something way more sophisticated than just fans.
The networking must be incredibly complex to handle all this processing power. How do they manage to keep everything connected?
That's where something called the spine leaf fabric comes in. Imagine it like a city's road system, but for data. Instead of having all traffic go through one central point, they create multiple parallel paths. And get this, they're already deploying 400G connections. That's 400 billion bits per second, with 800G coming for AI clusters.
The scale of this is almost impossible to comprehend. How do they even manage such complex systems?
It's all about automation. They've even created digital twins, virtual replicas of their entire infrastructure, to test changes before implementing them in the real world. And these networks aren't just in one location. Microsoft alone has added 120,000 miles of fiber just for their AI network.
That's enough to circle the Earth 5 times. But what about security? This seems like it would be incredibly vulnerable.
They've had to completely reinvent security for these environments. They use a zero trust model, where literally nothing is trusted by default. Every connection, every data transfer, every user access has to be verified. They're using technologies like microsegmentation to isolate different parts of the network, and encryption is everywhere.
The environmental impact must be enormous with all this power consumption.
You're right about that. Microsoft's emissions are up 30% since 2020, and Google's have jumped 48%. But here's what's interesting. They're actually leading the charge in sustainable technology. They're developing AI optimized cooling systems, signing massive renewable energy agreements, and creating circular hardware economies for recycling components.
It's fascinating how each company seems to be taking their own unique approach to these challenges.
Exactly. AWS has their custom chips like Trainium and Inferentia. Azure is focused on their global AI network. Google has their Jupyter network and TPUs. And Meta is pushing boundaries with their Open Compute project. We're really just at the beginning of the hyperscale era.
And yet, most people have no idea about any of this massive infrastructure working behind the scenes.
That's what makes it so remarkable. We've built this incredible, planet spanning system that's absolutely essential to modern life, yet it remains almost invisible to the average person. It's like we're building the foundation for an entirely new civilization, a digital one, right alongside our physical world. And the most exciting part? We're really just getting started.